Assalamualaikum and good day everyone. So today we're going to present for our group project of EPF 3001 Static and Strength of Materials. The title of our project is Mechanical Structure and Properties of Biscuit. So firstly, I'm going to introduce our group members. My name is Nur Atira binti Nur Hisham and I'm going to talk about the type of food. Next, we have Nordini Afina binti Norisma Carol Akmar and Hanis Mashita binti Ilyas, and they're going to explain about the measurement method. Next, we have Muhammad Hanif bin Rusli that's going to talk about the equipment needed. And lastly, Nur Nabiha Shazwani binti Kayarani, and she's going to talk about the mechanical properties of the food. So before I start, I'm going to give the introduction of this project. So the aim of this study is to analyze the mechanical structure and properties and their effect upon the properties of food with various of measurement method. So these biscuits are evaluated for its hardness and textural properties. By conducting this project, we studied about the strengthness, which is the physical properties of the food, the moisture content, the ash content, which are the mechanical properties, and the measurement method used in this project was also explained. Correlation determined in this project to study on the mechanical properties of the biscuit and the measurement method. I will go straight to the type of food that we choose for our group project, which is biscuit. So it is a flour-based baked food product, and it is usually made from flour, egg, salt, butter, and vegetable shortening with a baking powder. So as different type of biscuit come with particular mixing, forming, and baking process. It is also categorized as a healthy snack as it is hard, thin, and unleavened texture. Biscuits are also available in wide range of shape, colors, topping, hence accepted by consumers of all ages. The biscuit price also is relatively low and it is easy to find as a basic food item. Besides, it can be stored for a longer duration, and that is why biscuit has been preferred. Nowadays, biscuit consumption is rising worldwide.
Next, we move to the mechanical properties of the biscuits. So, let's take a look to the first mechanical properties of the biscuit. The first is fracturability. Fracturability is the tendency of material to fracture, crumble, crack, shatter, or fail upon of the application of a relatively small amount of force or impact. The textural property commonly possessed by baked goods, snack, and generally dry products. Fracturability encompasses crumbliness, brittleness, crunchiness, and crispiness. A biscuit is brittle if it is liable to fracture when it is subjected to stress or any load. It was a little tendency to deform or strain before fracture and usually makes a snapping sound. Fracture starts if the local stress is higher than the cohesive or adhesive forces in the material at that place. It spreading spontaneously if the deformation energy that is released when the material fracture is at least equal to the energy needed to create new surface. Fracture indentation and propagation depend on the presence of defects. Larger defects cause fracture to occur at lower overall stresses and strains. Peak force is usually the start of fracture. The force then falls either to zero if fracture is complete or fall partially if the fracture is incomplete. Fracturability single break is usually represented by characteristic sharp curve, usually a thin triangle shape. Next, the second of mechanical properties of the biscuit is hardness. The baker needs to monitor and control a baking line to improve the production consistency and provide information and for the proactive adjustment of formulation or recipe and oven profile to maintain an ideal and quality texture. The snap characteristic of hard and brittle biscuits were evaluated using a 3-point band assembly as an indicator of bake profile. The cookie sample is supported at 2 points. The travelling beam moves down at maximum speed and snaps the sample, creating a single massive fracture. For commercial, hardness properties can help to demonstrate the effectiveness of packaging in preventing moisture penetration from atmosphere in brittle products. Low moisture content enhances the keeping qualities of hardness of the biscuits. Biscuits differ from other baked cereal products such as bread and cakes by having a low moisture content. That's all from me. Thank you.
Okay, we're gonna explain to you the measurement method for strength test of the biscuit cracker. So let's go with the first step. Okay, using the scissors, punch two small the rim of the cup. The holes should be opposite to each other. Second step, cut a piece of string that is approximately 1.5 feet long. The string needs to be long enough to tie both ends of the cup and hang approximately 4 to 6 inches before the biscuits. Number 3, tie one end the string to one of the holes in the cup. Tie the other ends to the string to the opposite hole. Record the following dimensions, which is type of biscuits, the length of the biscuit, the width of the biscuit, and the thickness of the biscuits. Okay. And number 5, we're going to place a mat on the floor to protect the biscuit when it falls. Number 6, place the biscuits between the two desks, approximately approximately half inch or less of the biscuit should be touching each desk. Note which way that notch is facing and try to remain consistent throughout the experiment. Number 7, place the string and the cup assembly across the middle of the biscuits. Hanis Mashita gonna explain the next step.
Okay, next, using the funnel, start placing the pennies into the cup, one at a time. The pennies should be funneled in at a steady pace, ensuring that each penny lands in the cup before the next penny enters the cup. 2 to 3 pennies a second is a good rate. Try funneling the pennies in a way that they do not fall a large distance when they enter the cup. Next, continue placing pennies into the cup at a steady rate until the biscuit breaks. Number 10, record the number of pennies in the cup at the time of fracture. Number 11, look at the fracture surface and write down any observation. Then, find the mass of the cup, string, and the pennies into the cup at fracture using a mass balance. If your lab does not have the equipment to weigh these items, calculate the approximate mass of the pennies using 1 penny equals to 2.35 grams equals to 0.00518 pounds. Then repeat steps above for each biscuit to be tested. Next, measurement method. Hardness test for a biscuit cracker. Conditions imposed by the TMS Pro Texture Analyzer together with good experimental design accommodated natural variation in the sample set. A snap test was proposed to break the cookies at speed, creating a single massive fracture. Sample variation was removed from the 3 sample set. Each batch was checked for size, surface properties, breaks, and presence of large particulates.
Next is fracture behavior test, which we use a pendulum swing in the picture. So first, we have to place the device on a flat surface. check the pendulum is swinging freely and carry out one test without any sample inside in order to determine the amount of energy lost to friction, air resistance, and more. Zero the dial and place a sample on the supports. Raise the pendulum to horizontal. And next, when sure no one has their hand in the machine, release the pendulum so it falls and break the sample. Lastly, record the reading, remove the broken sample, and reset the dial for the next test.
So, let's see equipment needed to conduct the measurement, mechanical structures, and properties of biscuit. So, there are two types of equipment that we use to conduct the measurement method. So, first, TMS Pro Texture Analyzer. The TMS Pro is a fully programmable computer-operated test system for the laboratory environment. The TMS Pro Texture Analyzer has a capacity of 2,500 Newton in tension or compression, and so it can handle the most challenging of applications. Food technologists can manipulate forces and actions applied to the food samples by using its 200 probes and features. It is ideal for applications that require an accurate readings of position, pressure, and velocity. Combined with master stage application flexibility with texture lab or software, the broad variety of test setup configurations ensures that almost every processing condition inside the texture analysis plant or sensory system can be simulated. So we're going to the next equipment. It is fracture test rig. Okay. The fracture test rig consists of a pendulum of non-mass and length, which is released to hit an object from a non-height. The transfer of energy to the material can be determined by measuring the difference in hammer height before and after the fracture. The amount of energy absorbed in fracturing the test component is determined, and this provides an indication of the test material's toughness. A higher material of hardness will consume more energy upon impact and thus result in a low height at which the pendulum arm will swing at following impact. So that's all for the equipment needed to conduct the measurement method, and that's all from us. Thank you.